All right, so here note 7.7 for my, oh, that looks weird. 7.7 for my Algebra 2 honors class. Um, so we're going to do these three things, be able to use properties of logarithms to evaluate expressions. So this year we learned about logarithms, now we're going to learn more about how to work with them, be able to use a change of base formula to evaluate expressions, and be able to expand and condense logarithm using properties of logarithms. So that was a little thing on logarithms. So properties logarithms, so we went over this in class, so I'm going to go kind of faster through these, not so much of the explanation why, but more of just how to do it since I went over that in class. Product property, quotient property, power property. Basically, product property is that when you have the log base of a product, you can split the product into the sum of the log of both parts, and it'd be the same thing. Same thing with quotient. When you have dividing, you subtract. And then the power property is where you take the power, bring it down in front, and it's the same thing as multiplying the logarithm with the power in the front. So I went over reasonings behind that in class, and like I said, I'm just going to go over getting actual way to do this here. Common mistake here, there is no distributive property of logarithm, so please don't have this equal to log base b of u plus log base b of v, because the only way that works is if you have a multiplication. There's a product property, there is no sum property, so please don't do that. All right, so use property of logarithms to evaluate. Now, we already learned how to do this using the spiral. You might already be able to see this and say, okay, 5 to the negative 2 power is 1 over 25. But I want to show you that you could actually do this with properties of logarithms as well. So what you can do here, most obvious one, is the quotient property. So quo prod log, I think is what we said we'd call it. So I can do the logarithm of the top, same base, log base 5 of 1, minus the logarithm of the bottom, so log base 5 of 25. Now you can evaluate these using the definition. So 5 to what power is 1? 5 to the 0 power is 1. So this part right here, ooh, that was weird. What is that? Okay. This part is a 0. Minus, and then evaluate this one, just like how we evaluated yesterday. 5 to what power is 25? It's a 2. And 0 minus 2 is a negative 2. All right. So it turns out log base 5 of 1 over 25 is a negative 2. And you can check that because you can spiral around. 5 to the negative 2 power is 1 over 25. All right, let's take that off. All right, so next one. Now you can do a double spiral here. You could evaluate this log base 3 of 9, which is 2, because 3 to the second power is 9, and then 3 to the first power is that. 2 plus 1 is a 3. Or basically what I'm telling you is in your homework, you have to use a property of logarithms. Now, if you were given any choice you wanted to, you can do this all kinds of ways, but I want to see at least one property. So what I can do is, since I see this as a sum, I could actually put this back together using the product property. So if you see the equal sign, this goes back and forth. Okay, you can go back and forth between those. So this is the same thing as having log base 3 of 9 times 3. All right, so we're just putting it back together, which is log base 3 of 27. And then you can think 3 to what power is 27? Why, 3 to the third power is 27, so it's a 3. Okay, just like how we said at the very beginning. And last one, log base 10 to negative 4. So this one we can use the power property where that would just drop down in front. So negative 4 log of 10. Now keep in mind this is the common base. So technically there is a 10 down here, but you don't need to write it because it is the common base. Now if you want to write it because it helps you out, feel free to write it. But you should be thinking 10 to what power is 10. That way we can evaluate this piece right here. So 10 to what power is 10? 10 to the first power is 10. So that ends up being 4 times a 1, which is a 4. Okay. Oh, whoops, that's a negative 4. Sorry. Okay. Use property logarithms to approximate value decimal to 3 decimal places. So with these ones, I'm going to actually tell you some values of logarithms. Okay. So with this information, you need to be able to evaluate or approximate to 3 decimal places. So these two things I'm telling you, okay? These are approximations, so you can say, okay, 5 to this power is about 3, and 5 to this power is about a 7. Now this is where properties of logarithms come into play, because these next parts are not just a 3 and just a 7. Like 21, we don't know what log base 21 is based off of these. But you can use the information, because here's what you do. Log base 5. Now I know 21. I know. I know what log base 5 of 3 is, and I know what log base 5 of 7 is. So I know the 3 and the 7, but I have a 21. But I can make a 21 into a 3 and a 7. So that's useful. Now, using properties of logarithms, I can say, okay, well, I know that log base 5 of 3 plus log base 5 of 7 is the same thing as log base 5 of 3 times 7. All right, now I actually turned it into what I actually know. So I know log base 5 of 3 is 0.683. Actually, I could use approximation here. Is about 0.683 plus 1.209, because that's what log base 5 of 7 is. Because once I get log base 5 of 7, I can replace it with 1.209. All right, now it's just a matter of adding those two things together. So 0.683 plus 1.209, that's not a 9, that's a 9, is 1.892. So equals 1.892. So if you do 5 to the 1.892 power, 1.892 power, you should get a 21, or very, very close. Okay? Same thing here. Now we're going to use the quotient property to figure out these two, because I have to have log base 5 of just a 3. That's not happening here yet. So I'm going to rewrite this as log base 5 of 3 minus, because it is division, log base 5 of 7. I know log base 5 of 3 is about 0.683 minus 1.209, which is 0.683 minus 1.209, negative 5.26. Right, and then log of 49. So log of 49, that's log base 5. So remember, I want to try to get a 7 or a 3. 49 turns out is 7 squared. Then you can use a power property, which is going to say 2 times log base 5 of 7. And I know log base 5 of 7 is about 1.209, which is equal to 2.418. Alrighty, and there you go. Okay, quick time check. Change a base formula. You may change any logarithm base to a new base using this formula. So if you look at this formula, log base c of u equals log base b of u over log base b of c. Technically, the only base we're really going to want to turn it into in here is going to be base 10 or base e, because then we can actually plug it into our calculators and get a nice neat number. So for example, log base 5 of 25. So we already know the answer to this is 2, because 5 squared is 25. But using the change of base formula, if you notice, I can change this c base, right now the c is a 5, into any base I want. So let's go ahead and take out your calculator, and you can either make it log base e or log base 10, so whichever button you feel like pushing in your calculator. So you can turn this into log, and then the 25 goes on top, over log of 5, which you can plug into your calculator. Okay, so on your calculator, if you do log of 25, and then you divide it by the log of 5, you actually get 2. Okay, turns out, because that's log base 10, you can also use your ln button, ln of 25 over ln of 5. Okay, and you'll get a 2 also. So basically what this is saying is, if you just notice, we turned this 5 base into a 10 base, and it still worked. And we turned this 5 base into an e base, and it still worked. It's just that these buttons are easily pressed inside of your calculator. So that's where this comes in handy. Some calculators actually have a base change button, but just for uniformity, let's go ahead and just use this form of it. Okay. All right, use the change of base formula to evaluate the following, round to 3 decimal places if necessary. So let's try this out. So log base 3 of 7. Okay, first we're going to rewrite it, so it doesn't matter if you use ln or log. Let's go ahead and use log, I guess. Log of something over log of something else. So the question becomes, and this is where most people mess up, does the 7 go on top or the 3? Now if you notice, the 7 already looks like it's kind of like on the top. If you think of this like a fraction, 7 is kind of higher than the 3, so you can think of 7 going on the top and 3 going on the bottom, because that's basically how it's going to work. Okay, so log 7 over log 3, and then we're going to round off to 3 decimal places. So log 7 divided by log 3 is 1.7712437949. So 3 decimal places would be about 1.771. And you can check your work, do 3 to the 1.771, and you should get really close to a 7. Right? And that's how you evaluate it. Same thing here. Log base 4 of 8. First try a spiral. I mean, if you can figure that out with a spiral, don't even grab your calculator. But 4 to what power is an 8? 4 squared is 16, so you're already going to be in the decimals or fractions. So go ahead and use your change of base formula. Let's try this one with ln. Remember, it has to be the same base on top and bottom. 8 goes on top, 4 goes on bottom. Try plugging that in your calculator, and you should get 1.5. There you go. That's actually exact. It's not an approximation. Okay, 4 to the 1.5 is an 8. All right, and there you go. So that's change of base formula. Now we're going to expand and condense. We'll do a time check. Okay. So when you're expanding, there is somewhat of an order of operations here. Make sure you apply the product or quotient power properties first, and then apply your power property second. Now this is depending on where the power is, so this isn't really set in stone. These are kind of just general guidelines. So for example, this one. So I want to expand this. Basically what this means is I want to make this into more than one logarithm. Okay? So first off, I can see that there is what's it called? Products going on, but I also see a quotient. Now I'm going to approach this with the quotient first, since it's an entire thing divided by this entire thing. So what you're going to do is you rewrite this as 2 logarithms. It's going to be the logarithm of the top, so 7x cubed, minus the logarithm of the bottom. Now if you notice, that's expanded because I started off with 1 logarithm, now I got 2 of them. Right? Now it turns out I can split this up more, because I have, remember, you should do the quotient and product stuff first. There's no products over here, that's just a y. But over here I got a 7 times an x cubed. Now do not, I repeat, do not bring this 3 down front right now, because if you bring the 3 down front, that implies that you had log base 2 of 7x, this entire 7x thing to the 3rd power. Right now it's just the x to the 3rd power, so we got to separate these two first. So I'm going to expand it some more. Now I'm going to end up with 3 logarithms. First is log base 2 of 7. Since it is multiplication, I'm going to add log base 2 of x to the 3rd power. And then this minus log base 2 of y just kind of hangs on to the end because there's nothing going on there. So remember, you're looking for products, quotients, and powers. So we took care of the quotient. We took care of this product right here. Now we got a power. So that's going to be the last thing. When you have a power, you can bring it down front. Okay, so this will be log base 2 of 7 plus 3 log base 2 of x minus log base 2 of y. Now double check it, make sure that there's no more products. Okay, looks like there are no more products. There's no more quotients. And there's no more exponents that I can simplify, so you are done. That's how you expand. Okay, check for products, quotients, and exponents. Once you simplify as much as you can, you stop. Okay, so I'm going to do this one. Make sure you state the property of each step. So this one is going to be log base 5. You have 2 times x to the 6th. So that's going to be 2 plus log base 5 of x to the 6th. That is the product property of logarithms. Log base 5 of 2, there's nothing really about that that can be expanded. There's no multiplication going on. There's no quotient. There's no exponent. This other one has a 6 up here. So bring the 6 down. So 6 log base 5 of x. And there you go. right? That's expanded as much as we can expand it. Okay, so let's go ahead and, well, let's do this one. Um, now, you got to be kind of careful with this one because there is a little bit of, so well, let me show you. So log base 7 of y minus, because there is a quotient here, um, log base 7 of 3x squared. All right, so the log base 7 of y stays the same because y is just y. Now, the split apart, it's not equals. The split apart here, you got to be kind of careful here. So what you want to do here is, so log base 7 of 3 plus log base 7 of x squared. Since this could be kind of misinterpreted to say that you're going to have, because if you write this back, some people might see this as y over 3 times x squared, which is not true because x squared should be on the bottom. So you got to throw some parentheses in here because this entire thing is on the bottom. So that entire thing, that has to come first, okay? Order of operations. So we're going to do log base 7 of y minus log base 7 of 3 plus bring down the 2 using the power property, log base 7 of x. And that should be your answer. All right, now condensing. So now that we expanded, now we got to learn how to condense. In order to condense, you got to apply the power properties first, apply the product or quotient properties last. Now, like I said before, these are just kind of guidelines. You don't have to do it like this every single time. So looking at this, you see a plus, which means multiply, so you're going to be multiplying at some point. You see a minus, which means you're going to be dividing at some point, and you see a power. So the first things we want to take care of, since we are condensing instead of expanding, is your powers. Keep in mind that we did the powers last time. So now that we're going backwards, we're going to do it first. Okay? So there's going to be log of 6 plus, now this 2 right here is going to go right back up in the exponent. So this is going to be kind of shrinking down. We got 3 different logarithms. We're going to try to make it into one logarithm. So 2 squared minus log of 3. All right, so let's go ahead and do this order of operations. We're just going to go from left to right. There are no parentheses, so this will be, so we're going to multiply. So that's going to be 6. That plus sign means multiply times 2 squared minus log of 3. Okay. Now let's handle that minus sign. These are going to come together and make a log of 6 times 2 squared over, because subtraction means division, 3. We can simplify this out a little bit more. So what is that? 3, 2, 4, 8. Log of 8. Right? And if you notice, this is a lot more condensed than that. But they are exactly the same thing if you plug them into your calculator. Okay? And there you go, that's condensed. Let's do one more, then I'll stop there. Okay, so this one, make sure you handle your exponents first. So this is going to be log base 3 of 7 squared minus log base 3 of x to the 5th power. Now we see subtraction, which means division. So it'll be log base 3 of 7 squared over x to the 5th power. You can go ahead and clean up the 7 squared a little bit. So it'll be log base 3 of 49 over x to the 5th. There you go. Excuse me. Okay, and that is all. I guess there's another one. I'll go over this one just to help you guys out. Have another one. You don't have to keep listening. You can stop. I don't think I'm going to say anything important. And if I do, I'll put a little whatever notation thing. Okay, so it'll be log base 8 of x squared. Handle your exponents first. 8 of 5 stays the same. We got a 3 there, so that's going to go up top. So it's going to be minus log base 8 of y to the 3rd power. Okay, so I got a subtraction. Then I got another subtraction. So that's interesting. Division of a division. So that's going to flip over, I believe. So let's do this. So this will be log base 8 of x squared over 5. Okay. Minus log base 8 of y to the third also. So let's see here. So you're going to take that divided by that. So log base 8 of x squared over 5. Let's write it this way, because that's dividing, right? Divided by y to the third. Dividing the same thing as multiplying by the reciprocal, so that will end up on the bottom still, right? Yep, that flips over. So this is going to be log base 8 of x squared over 5y to the third. There you go. Okay, that last one might be kind of tricky, but try it out. See if it makes sense to you or ask me questions tomorrow. Okay, bye-bye.